Hi, welcome to 3.4. We're going to go over common functions and piecewise functions. I call common functions parent functions sometimes, and that is because after this lecture, we're going to talk about how to change or translate a parent function by putting a number in front of the x, putting a negative sign in front of the x, adding a number at the end, at the back, something like that. So these are called parent functions because these are the foundation. And then in 3.5, we'll talk about how to change the parent function a little bit, but they are also called common functions. So that's the title of the lecture. I would recommend, didn't know where I was going with that sentence. I would recommend using Desmos frequently for this, okay? So first, we're just gonna start out by graphing. What does it mean when they ask us to graph something like y equals a number? Remember that y equals is the same as f of x equals, okay? So we'll go over common functions or parent functions, and then we're going to go over piecewise functions. A piecewise function is when you have maybe f of x equals 3 up until x equals 0. So for when x is less than or equal to 0, our equation is f of x equals 3. And then maybe after that, when x is greater than 0 or greater than or equal to 0, it becomes f of x equals x and starts doing something else. So a piecewise function is going to look different. It's going to be two different functions depending on where it is on the x-axis, which is confusing, but you'll see a visual of it and that will make sense. All right, to start with, we're basically creating a table of values, of x, finding y or finding f of x, and then plotting those points so that we can graph. Again, use Desmos if that comes easier to you, if that's simpler. The numbers I'm going to try to stick to using are -2, -1, 0, +1, and +2. Because those are small numbers, you can graph them kind of easily because they should be right along here, okay? So all this equation says is y equals, and then a c for constant. Y equals a number. We've covered this. When y equals a number, oh my goodness. When, I just noticed that I have a broken straight edge. When y equals a number, it's going to have a slope of 0, and it's just going to be a horizontal line, right? So there is not even an x for our equation, but if x were -2, y would still be 3, so that point will be -2, 3, right? When x is -1, y is still 3, so -1, 3, and I think you can see where this is going and why, in some circumstances, Desmos is faster. As I make mistakes while I try to talk and write at the same time. When x is 2, y is still equal to 3, so that's just going to be the point 2, 3. Here's 3 on the y-axis. So -2, 3 is maybe here. -1, 3, 0, 3, 1, 3, and 2, 3. I can't really reliably make a straight line. Graph the function f of x equals 3 is going to look like this because it's just y is 3 no matter what x is. Now, this is called the linear function. It's going to make a straight line, and it's going to include both y and x, right? Because f of x is just y equals. F of x is x is the same as y equals x. It's just that y equals x is a function, so we can call it f of x equals x. Again, use -2, -1, 0, 1, and 2 for my x-axes. -2, -1, 0, 1, and 2. F of -2 makes y -2. So that point is going to be -2, -2. F of -1 gives us -1. So that's going to be the point -1, -1, because my x is -1 and my answer is -1. When x is 0, the whole function equals 0. When x is 1, my whole function equals 1. If you're feeling the desire to skip this and go straight to Desmos, just hold on 1 second. So that I can show you, make sure you know how to find a table in Desmos as well, a table. So -2 is going to be this guy, -1, -1, 0, 0, +1, +1, +2, +2. So that is a linear equation, y equals x or f of x equals x. Good. All right, let's go to Desmos. Ignore. Oh, so there's a piecewise function. So until x equals 1, it looks like the line 2/3 x plus 1. And then after x, at and after x equals 1, we have -2x plus 1 down here. That's a piecewise function. All right, here was our constant. And here is our identity function or linear function because it's a line. Remember that you can just press this edit list and it will give you the choice to show the table of the equation you put in. So when f of x equals x, when x is -2, y is going to be -2. When x is equal to -1, y is going to be equal to -1. 0, 0. Okay, so they will give you the table of some of the functions we're making here. So when they ask you what is f of 2 of f of x equals x, you can say f of 2 of f of x equals x is equal to 2, which is what we got as well. F of 2 is 2, which is the point 22. Square function just means we took the x value and we squared it, okay? Create a table of values using the same ones, -2, -1, 0, 1, and 2. And remember, those are our x values. So f of -2 is going to be equal to, now we're getting into an actual equation we can work. So -2 squared. Remember your parentheses. Children. All right, I had to pause that recording. Remember to use your parentheses. The square -2 squared needs to have parentheses around it. That's going to give you the wrong answer if you don't use parentheses. Okay, always use parentheses. So f of -2, when we're talking about the square function, x is -2, but y is, we saw, 4. Okay, f of -1 is -1 squared, which is 1. So that's going to be the point -1, 1. 0 squared is still 0. So we're going to go through the origin on this graph. Less important using parentheses when you have the positive. 2 squared is 4. So that's 2 and 4. Okay, so these points are, let's start with 0, 0. That's the point 0, 0. Then we have the point 1, 1. Then we have the point 2, 4. Over here we have -1, 1. And then we have -2, 4. Good. So that is the square function. When you get y equals x squared, it's always going to look like this. On Desmos, here it is, okay? And then what we mean by I'm going to transform it is maybe we put a -3 over here. It gets bigger, or it gets lower, sorry, it does not get bigger. Let's zoom out. Good. So -3 made it lower. Plus 2 makes it higher. X, what if I put some stuff in parentheses? X -1, moved it over to the right. And then maybe 3x squared made it narrower. But you can see that our base function is x squared, and then depending on what we do to it, it changes the look of the original x squared. So that's why it's called the parent function. Again, if you want to find your x values for that, they will create the table for you. There's your table with some helpful values on the table. And that's the graph of it. All right, x cubed. So -2, -1, 0, 1, and 2. F of a -2 is -2 cubed. -2, again, just put it into your calculator. -2 cubed is a -8. Good. -1 cubed is -1. 0 cubed is still 0. Oh, sorry, -1, -1, 0, 0. 1 cubed is going to be 1. And then 2 cubed is going to be a +8. So the cubed root looks very different as a graph. We still are going through the origin. We're still going through 1, 1, but instead of going through -1, 1 like we did for the square, we're going to go through -1, -1, and then we're going to go through -2, -8, +2, +8. So it's more of a symmetry with respect to the origin, whereas this guy had symmetry with respect to only the y-axis. Okay, so that's x cubed. Now the square root function. All we're going to do is take x and get the square root of it. So I'm not going to start with -2 because the square root of -2 is not, oops, I'm sorry, you couldn't see that. Start over. The square root, you already see it though, the square root of -2 is not a real number. So I can't even graph the square root of -2. And the square root of 2 is going to be a decimal. I don't want that. So I'm just going to take perfect squares. Okay. The perfect squares I know are, is 0 perfect square, are 1, 4, 9, and 16. Because if we think about it, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. So that's going to be an easy way. These are going to be easy numbers to plot. The square root of 0 is 0. So that's going to be the point 0, 0. The square root of 1, so we just take the x and put it under the radical. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. And we saw how for this guy, because we're squaring it, we're getting really big y values for small x's, right? And here we have big x values, small y values. So you're kind of doing this kind of thing, but you're putting it on its side. So it's going out instead of this one's going swooping up. This one's going to swoop out, and you can't do a negative, right? The -16 is going to be not graphable. So the square root function does not exist below 0. You cannot put a negative number here, so there's not going to be a graph over here, here, or here. Can't be below the x-axis. And you're not going to square a number and get a negative on the y-axis. Anyway, so we got 0, 0, we got 1, 1, and then we got 4. We got to go all the way out to 4 to go up to 2. And then we got to go all the way out to 9 to get up to 3. And then all the way out to 16 to get to 4. So this is just a very slow graph like that. Okay? That's the square root function. Absolute value function. Think about the absolute value of our small numbers, -2, -1, 0, 1, and 2. 0 and its neighbors, right? So f of -2 is equal to the square root of -2. The square root of -2 is just 2, right? -2, 2. -1 is going to be the same. It's going to be a +1. The absolute value of 0. How far away is 0 from 0? It's 0 away, 0 units away. Absolute value of 1 is just a +1. And then the absolute value of all your positives are just going to be kept the same, right? So what is the graph of the absolute value function? We got 0, 0. We got 1, 1. We got -1, 1. We got 2, 2. We got -2, 2. So the absolute value function is actually all my y's are always positive, even if my x's are negative. So it'll never be below the y-axis because the y's will never be negative. And then for x, even if my x is negative, my y is still positive. And it goes up in exactly the same. So basically over here, it's the same as y equals x, right? And then over here, we take y equals x and we just flip it across the y-axis or send it up in that direction. Okay, so that's the absolute value function. Reciprocal function. Remember that a reciprocal means you flip it across the fraction. So we had y equals x, the linear function, and then the reciprocal of the linear function is y equals 1 over x, because we moved x to the bottom of the fraction. First, we turned x into a fraction by putting it over 1, and then we moved it to the bottom of the fraction, so we call it the reciprocal function. So the reciprocal function of -3, -2, -1, 0, 1, 2, and 3. Ugh. Fractions. Good. And then graph it. So f of -3 is -1/3, right? So when x is -3, y is going to be -1/3. And I think we know where this is going. When x is -2, y is going to be -1/2. When x is -1, y is going to be -1. Good thing I'm writing this out. When it's 0, 1 over 0. What happens if you put 1 over 0? Does not exist. Okay, so that is a hole in your graph. 1 is going to be 1. 2 is going to be +1/2. 3 is going to be 1/3. Good, so let's graph these. I think the biggest you go on y is 1. I guess -1. All right, from -3, -1/3, -2, -1/2, -1, -1, 0 doesn't exist, 1, 1, 2, 1/2, 3, 1/3. This is an interesting graph. Okay, let's look at it in Desmos. So we saw that one, we saw that one. Now we're on to this one. What happens? It can't exist at 0. So these are two, each side of the graph is approaching 0 and approaching positive infinity on the y-axis. Okay, so it's getting really, really big on y. And then as it approaches 0, but it never touches 0, right? And then as the x gets greater in the negative x and positive x directions, your y is getting smaller and smaller and smaller and smaller and smaller, but it's never going to touch the x-axis. So that's an interesting graph. It's a hard one to graph, but basically you're going like this. You might be wondering, how do you know though that it goes up? Because if you get something that cannot be graphed, you can also take something close to that number and say, well, what is it doing right next to f of 0, right? So if f was 1/2, right? Then we would say 1 divided by 1/2 is 2. Good. So I know that when x equals 1/2, y is already 2. When x equals, and we get closer and closer to 0, we get a bigger and bigger number because that bottom of the fraction is going to become your whole number. When f is 1/100, it means we have to take 1 and divide 1 by 1/100, and we're going to get 100. So as we get closer and closer to 0, our numbers are getting bigger and bigger. Good? That's a way to check that. Or use Desmos. All right, moving on to 2 examples of piecewise functions. Make sure you understand this. This is complicated, okay? I should have made that bigger. I'll try to make that bigger on yours, the graph. A piecewise, oh no, let's not do piecewise functions yet. Let's review these, okay? Let's review these. So the ones we have done are, we did the constant, y equals, I shouldn't do it like that, okay? Constant, y equals 3 was our example, right? What does the graph of the constant look like? It just looks like this. You can't even see what I'm doing. Too excited. All right, so there's the constant. So ignore that, I think. Still formulating how I'm gonna write this out. After that, we have the linear. Y equals x, right? Y equals x looks like this. It goes through the origin, and then x and y mirror each other. So when x is 1, y is 1. When x is -1, y is -1, okay? That's our linear equation. You should be able to picture these in your head. When you see y equals x, you should be able to picture this graph in your head. When you see y equals and then just a number, you should be able to picture a horizontal graph through that point of y with a 0 slope, okay? After constant and linear, we have, I want to get the names right, the square function. Good? Square function because x is squared. Remember also that this is the same as f of x is 3, f of x is 2, f of x, oops, sorry, is x, f of x is x squared. Good? Y equals 3 is the same as f of x equals 3, just to be that reminder. Good? All right. X squared, it goes through the origin, and then it's rising at the same steep angle on both sides of the y-axis. After the square function, we have the cube function. Why is it a cube? Because now x is being cubed. What happens when we cube x? Instead of having a parabola in the upward direction, we have kind of half a parabola, and then that parabola goes on to mirror itself across the origin. That's the cube function. Then square root. Square root function, y equals the square root of x. Remember that that's only in this quadrant, and it looks like half of this, looks like we moved that over and cut off half of it, okay? Then we have absolute value. Because these are all functions, they can all be f of x equals x. Our absolute value is exactly like y equals x, except that there are no negative y values. So when the linear equation had positive y values, it mimics, the absolute value mimics the positive y values of the linear equation. And then for all of the negatives of the linear equation, we move those to positives. So all of these negatives now go right up here because the absolute value of x is going to be the same as x, but it's never going to be negative in the y direction. So the negative x's become positive y's for absolute value. After absolute value, what did we do? Let me see. And then we just did reciprocal. Reciprocal was f of x equals 1 over x. This one's a hard one, but what happens is we approach both the y-axis and the x-axis. I never touched. So those are the parent functions. When you see that, picture that. When you see that, picture that without graphing it. When you see that, picture that. When you see that, picture that. When you see that, picture that. You know what I'm saying. I can stop saying it. That's why I wanted to pause and review. So after that, but what happens is we approach both the y-axis and the x-axis. I never touched. So those are the parent functions. When you see that, picture that. When you see that, picture that without graphing it. When you see that, picture that. When you see that, picture that. When you see that, picture that. You know what I'm saying. I can stop saying it. That's why I wanted to pause and review. So after that, we are going to talk about piecewise defined functions. Intervals of multiple functions, okay? Interval means this part. When x is less than 1, on the interval, x is less than 1. So the interval for that would be x is less than 1. X is less than 1 means from negative infinity to 1. We're going to do this. 2/3 x plus 1. Okay. This interval means from and including 1 to positive infinity. So that's the simplest way to explain a piecewise function. For this part of the graph, we're going to do this equation. For this part of the graph, we're going to do this equation. So from negative infinity, right, up until 1, we're going to do this graph. We're not going to include 1, so that is not included, okay? And then from 1, including 1, until positive infinity, from 1, oops, sorry, you can't see that. From 1 to positive infinity, and do this graph. And that does include 1. All right, so those are the intervals. Basically, the graph goes on forever and changes at 1. It goes on forever in this direction from negative infinity, stops here. Here it jumps down. It doesn't exist. This line does not exist at 1. This line does exist at 1. So as we approach 1, we jump down here and we continue towards positive infinity. We start at negative infinity on this graph, jump at 1, because we cannot include 1, but this one can include 1. Jump as soon as we get to 1, and then go this way forever, okay? That is what a piecewise function is. And it can have 2 parts, it can have 3 parts, however many parts, okay? That's what they mean by piecewise. I also want you to look at, we have 2/3 x plus 1, and we have negative 2x plus 1. What are these? What are the parent functions? What is happening to x? Remember, we said parent functions are the things that you start with, and then you add 1, or you put a number in front of it. So what this one is, 2/3 x plus 1, is actually a linear equation. It just has a multiple 2/3 in front of it and a plus 1 added to the back. So that's still a linear function. And then our other option was negative 2x plus 1. What is the parent function of negative 2x plus 1? Well, if we get rid of the plus 1 and we get rid of the negative 2, our parent function is just that original linear equation. So these are both just linear equations. Okay. And it doesn't matter if you put f of x equals, y equals, or just nothing and start typing it, that's fine. Yeah, 2/3 x plus 1. All right, so here are our 2 graphs, but we're going to switch at 1. Okay, at 1, we're going to go from, how dare you make these the same color? All right. At, okay. Here is the graph, 2/3 x plus 1. All right. We're going to use that until we reach 1. After 1, we're going to use the graph negative 2x plus 1. Okay. So we're going to have this graph, and then at 1, we're going to stop. We're going to come down, and we're going to try to find where 1 is on this graph, right? The way you do that is just type it in Desmos. Okay, so this is what we're looking for. Notice on our paper it says f of x equals 2/3 x plus 1 if x is less than 1. That is not how I typed it in. What I typed in was x is less than 1, and then I put a colon 2/3 x plus 1. But the reason I did that is because then it stops it for you. If I just put in 2/3 x plus 1, they're going to give me my whole line, right? But if I put in a x less than 1 in front of it, they're going to stop my line before x gets to 1. All right. Same thing. You have another one that says if x is greater than or equal to 1, so begin with x is greater than or equal to 1, colon, and then your equation, negative 2x plus 1. Good. So here's the graph that they're asking you to graph. You can even take a table of it. Okay, so let's look at, that's why I included this down here below. Here's how to enter it into Desmos, because it's a bit the opposite of how it's written. You start with this one, put in a colon, and then put in your equation. Okay, so what we're going to do is x is less than 1 for 2/3 x plus 1, comma, x is greater than or equal to 1, colon, negative 2x plus 1. If you type that into Desmos, it will graph this for you, okay? Then you press that gear, create your table, and they will find f of 0, f of 1, and f of 2, okay? You can also graph it by creating your own table like we did with all of those other ones, right? If x is -2, put it in there. What point do you get? You can do that as well, okay? Now use your table or use these equations, use the table in Desmos, or use your equations to find f of 0, f of 1, and f of 2. Let me come down here, B. B is asking for f of 0. Well, now that I've graphed it, I can see that f of 0, when x is 0, we are talking about that first equation. Let's write down what that equation is. Positive 2/3 x plus 1. And then this guy is -2x plus 1. So once I've graphed it, I can see that f of 0 is 1, right? I can just see that. F of 0 is 1. And that we're talking about this equation, so I can check it. 2/3 times 0 plus 1 is, 2/3 times 0 is 0, plus 1 is 1. Good, because I knew to use this equation, because I don't have an f of 0 for this part of the equation. This part of the equation doesn't exist where x equals 0. It begins existing where x equals 1. Okay, so that's f of 0. F of 1, when x equals 1, y equals -1. Different color? I don't know. I'm gonna run that color. Good. When my x is 1, my y should be -1. And I'm going to start using this equation, so you're also welcome to put it into your equation. -2 times x is 1, plus 1. -2 times 1 is a -2, plus 1 is -1. Okay, so I can do it algebraically, or I can just look at the point. And my last one is, what is f of 2? Then they ask, what is f of 2? F of 2, I can see, is going to be over here, right? Here was 0, 1, here's x equals 2. That's what that means. F of 2 means x equals 2. When x equals 2, y equals -3. I know to use this equation, so I can just plug it in. -2 times x, which is 2, plus 1. -2 times 2 is a -4, plus 1, which is -3. Okay, so you can use algebra, use these equations, or you can find the point on the graph on Desmos, okay? So they asked us to find f of 0, f of 1, and f of 2. F of 0 was 1, f of 1 was -1, and f of 2 was -3. Find the domain and the range, okay? Look at your graph. What is the domain? The domain is all your x values. It's going to go forever in the negative x direction, and it's going to go forever in the positive x direction. This has a hole in the graph, but it's covered by this where it fulfills the graph. So there are no holes in the graph. So I'm just going to say x is all real numbers, -infinity to infinity, okay? And then the range what is my range? My range is, it does not go higher than the y value when x equals 1 on this equation, right? This is a hard one. The range is hard for this question. So I see that the graph stops here, right? At x equals 1. What is my y value when x equals 1? I don't know, but I can find out. All right, when I put an x in here, what is y? Y is 2/3 x plus 1 is the graph we're working with. And the highest the graph goes is when x is 1. 2/3 times 1 plus 1 2/3 times 1 is just 2/3. 2/3 plus 1. Oops, sorry. It's just 5/3 or 1 1/3, right? So my y value here is 5/3. So that'll be x is 1, y is 5/3. And that's as high as my graph is going to be. It's going to be here and below. Right? So my range is below or less than 5/3. Negative infinity to 5/3. And remember, it doesn't include that, but it goes right up to it, right? Just like the whole graph doesn't include x equals 1, but it goes right up to it. Domain is all real numbers, forever in this direction, forever in this direction. Range is from negative infinity all the way up until we hit 5/3. We do not include it because that's a hollow circle. I know that was hard, but I hope you understood it, and we'll do one more example, okay? Locate any intercepts. Another really good reason to use Desmos for this question, because they'll tell you, here is an intercept, and here is an intercept, right? This one does not intercept the x-axis or the y-axis, but this one intercepts the x-axis at negative 1.5. Negative 1.5 would be negative 3/2, 1/2, 2/2, 3/2, negative 3/2, and they already give us that one, 0, 1. And they didn't say to put it in fraction form, so maybe it's okay to just put negative 1.5. All right, let's talk about these answers in once you've already graphed it in Desmos. Okay, so we've graphed it. They ask us find f equals 0. All right, sorry. Let's get rid of everything else. Don't want to confuse you. All right, we're not talking about this one because this one is example 2. We'll get there. Here we have x is less than 1, colon 2/3 x plus 1, because that fulfills the first interval. Our second interval is negative 2x plus 1 if x is greater than or equal to 1. So I start with x is greater than or equal to 1, put a colon, and then put negative 2x plus 1. If you can't find your greater than or equal to or less than or equal to on your keyboard, you can go to show keypad and they will type it in for you. Here's the absolute value button. Here is the radical, and here is the greater, less than or equal to, and greater than or equal to. So that's what that keyboard is for. Okay. Now find f of 0. So edit list, you want the table for this green line, right? Now they said find f of 0. That means find x equals 0. So you can just type it in, or you can look right down there and see that they've already typed it in. They wanted you to find f of 0, f of 1, and f of 2. So you type it in, make them find it for you. You found it. When x is 0, and then they'll find that point for you as well. When x is 0, y is 1. When x is 1, y is negative 1. And when x is 2, y is negative 3. So they'll put it on the table as you type it into the table. Sorry. As you type it into the table, they start creating that point for you. So I don't have anything on my table. I want to know what x equals 0 is. They put it on the table, or they put that point on the graph. I want to know what x equals 2. They put that point on the graph. X equals 3. They put that point on the graph. Good? Okay, and then find the domain and the range, locate any intercepts. Even without the table, Desmos shows you the intercepts. Okay, and then you just click on it and it gives you the precise point of it. 0, 1, negative 1.50. So that's how you find the intercepts, okay? Let's do our next one. This one's harder. It's harder to enter f of x equals 2 if x equals 2 into Desmos. So I would recommend just putting in negative 4 less than or equal to x less than 2 colon so in Desmos, open a curvy bracket, negative 4 less than or equal to x less than 2 colon x plus 2 comma, remember, start with this one, start with your limitation, x is greater than 2 colon x squared minus 5, close your bracket. You can also just make this its own bracket and this its own bracket. It'll still show up the same, but it's better to put them together because then when you do your table function, it will show you the table for that entire set, okay? If you do it separately, it'll still work. But if you do them together with just a comma between them, you will have a better table. You'll have more information on your table instead of splitting it into two different tables, okay? So they're asking us to graph it, find f of 0, f of 2, and f of 3, find the domain and range, and then locate any intercepts. Again, the fastest possible way to do this is through Desmos. So let's do it together on Desmos. I guess I should have erased it because we need to do it together. Let's get rid of that guy. Open your curly bracket. It says f of x equals x plus 2 if negative 4 is less than or equal to x is less than 2. So start with your limitation, negative 4 less than or equal to x less than 2, colon, good, x plus 2. If I were to close that and just give you another one, bracket, x is greater than 2, colon, x squared minus 5, close that one. It'll work. You can still see how this one ends right where this one starts, but when I go to make my table, some of your answers will be undefined. Whereas if you put them together with a comma, you'll have a more complete table. I have to redo the table. Okay, sorry. Don't cut and paste mid after you've already created the table. All right. So if they were two separate tables, you wouldn't have if they were two separate equations, you wouldn't have such a complete table. So it's better to just put a comma, put them all into one. All right, so they ask us to graph it. If we were to graph it, it would look like this. This one's a straight. Ooh, let's talk about that real quick. Let's talk about what we have. We have x plus 2. That is the same as x, right? So that's linear. That means it's going to be a straight line. And then what is the basis of this one? X squared, right? So that's a square function. So this is just x plus 2, so it's going to look like this. But this is a square function, so it's going to look like this. It's going to have a little curve to it, and it's going to be a parabola. I guess technically it could be both sides of it, right? All right, so that's what you should expect to see. Remember, we want to be able to picture this in my head. X plus 2 is a linear equation. 2 is that guy. X plus 2 is this guy. X squared is this guy. So that's why we're learning the parent function, so we can picture this. The -5 means something, but I can picture x squared in my head. The 2 is just a line at 2. X plus 2 is the f of x equals x is a linear diagonal positive slope where x equals y. Okay, so we're picturing those. We've also put them into Desmos, and that fits, right? We have the x plus 2 right here, and from -4 until +2, but we didn't include +2, and so that's why we have an undefined. We have a hole in our graph right there. But at 2, I didn't include that, sorry. At 2, x equals 2. At x equals 2, y is 2. So that's going to be part of our graph. I didn't explain that. I apologize. And then after 2, right, when x is greater than 2, it's going to take on this form. So there are actually 3 different graphs, right? When f, and then it asks us to find f of 0, f of 2, and f of 3. Then to find the domain and range, and then locate any intercepts. So the same exact thing as example 1. Let's talk about part B. What is f of 0? What is f of 2? And what is f of 3? Okay, look at your options. F of x equals 2 when x equals 2. So f of 2 is going to be 2, because that's just the point. 2, 2, because of what they gave us. And we didn't even graph that in Desmos as part of the brackets. We just know that the point 2, 2 is included in it. When x equals 2, f of x equals 2. So that's the point 2, 2. Okay. F of 0, is that going to be between -4 and 2 or above 2? It's going to be between -4 and 2. So we're going to use the equation x plus 2. So it's the equation x plus 2, but x is 0. 0 plus 2 is 2. So that's going to be the point 0, 2. F of 3, is that going to be between -4 and 2 or above 2? It's going to be above 2, so we're going to use the equation x squared minus 5. Instead of x, we're going to put 3. So 3 squared minus 5 is 9 minus 5, which is 4. So that's going to be the point 3, 4. Good. So that would be how to figure it out algebraically. F of 0, we're going to use this graph because 0, x is 0 between -4 and 2. F of 2, we're going to use for x equals 2, and it gives us the answer that it's 2. And then f of 3 is greater than 3 is greater than 2, so we're going to use the equation x squared minus 5. When I put 3 in for x, 3 squared minus 5 is 9 minus 5, which is 4. So on our graph, we should be able to find the points 0, 2, 2, 2, and 3, 4. Let's look in Desmos. Sorry. Again, here's our graph. Here's our table. They asked for when x is, they didn't ask for these. Good. They asked for x is 0, y is 2. F of 2, it's not on here. It's considered undefined, but it is the point 2, 2. And then when x is 3, y is 4, or the point 3, 4. Okay? I don't think they asked for 1, so I'll delete that to be less confusing. Don't be confused by Desmos. All right, when x is 0, y is 2, they put that point. When x is 3, y is 4, they put that point. And then we also know that the point f of x equals 2 when x equals 2 is on there. So that's that point. I added that separately. Okay, so that was finding f of 0, f of 2, and f of 3 either on Desmos or algebraically. Find the domain and range. What is the domain and what is the range? It's not negative infinity to positive infinity, right? On x, it's going to be between -4, right? X is greater than, but it does say greater than or equal to, right? X is greater than, greater than or equal to -4, right? And then it goes on forever. What would be the interval notation for x is greater than or equal to -4? It's from -4 to infinity, right? On the x-axis. Let's look at our range. Our range is from this point up, right? Y is greater than or equal to -2. How do we write that in interval notation? -2 to infinity. Good. Why do we know that that's true? Because what can x be? X can be greater than or equal to -4. It exists, and then it can be less than 2. It exists at 2, and then after 2, it exists forever, right? And then the range, again, is very difficult, but what we want to do to find the range is, just like we did with the previous equation, was, let me pause this. Turn everything else off. All right, so for our previous one, we had to find, sorry. Just let me touch it. We had to find the y value of our highest x, right? And we said that when x is 1, right here, for this half, that's going to be the highest y ever gets, right? But it's never going to fit there because it was x is less than 1. And so we found that when x is less than 1, y is 5/3. So at the point 1 5/3, that doesn't exist, right? It's going to be below that. So when y is less than 5/3, that's greater than. Y is less than 5/3 is my range, because 5/3 was the y value of my highest x. Okay, so same thing here, right? That is my range. And for these, this is my range. Everything above -2. Okay? For this one, everything below and not including 5/3. For this one, everything above and including -2. So that's what we need to do to find the range. It's definitely the most difficult part, but you can do it. Locate the intercepts. Just go straight to Desmos. What are the intercepts? The intercepts are, sorry, that's the wrong one. The intercepts are here, and they will label them for you on Desmos, -2, 0, and 0, 2. Which equation are we talking about? We're talking about the equation between, ooh, there's 3. So for the equation between -4 and 2, we have 2 intercepts. And then for the other equation, we have 1 x-intercept. So our intercepts were -2, 0, 0, 2. And then we have 2.2360. If you want to do it algebraically, you're welcome to do that. What you need to do is take each of those equations, x plus 2, to find your x-intercept, we set y equal to 0. So 0 equals x plus 2. We just move the 2 over. X is -2 when y is 0. So that's the point, -2, 0. Now we make x 0. So we have y equals 0 plus 2. Y is 2 when x is 0. So that's the point, 0, 2. Right? X is -2 when y is 0. That makes the point -2, 0. Y is equal to 2 when we make x 0. So that makes the point 0, 2. And then check it for your other one. So x is greater than 2, so there's not going to be a possibility that x equals 0. So we're just going to take y equals 0. X squared minus 5 is y. We said that y equals 0 can exist, right? Y equals 0 can exist. Y can exist. Y equals 0. So 0 equals x squared minus 5. Add 5, we get 5 equals x squared. To get rid of the x squared, we have to take the square root. Good. So we have negative square root of 5 and square root of 5 when y equals 0. So those are the points. However, we have to exclude this one because well, that's good. That is the right answer, right? So that was that answer we found in Desmos. And negative square root of 5 is less than 2, right? And x has to be bigger than 2. So we have to eliminate that one because we can only use numbers where x is greater than 2. That's not greater than 2. So we're only going to count this one. And then if x is 0, let's just test it out, okay? Y equals 0 squared minus 5. Y equals -5. But just like, so that point would be 0, -5. But just like this one cannot exist because x cannot be x must be greater than 2. So it can't be negative square root of 5 and it can't be 0. Again, this is all, it makes sense, but it's much easier to see in Desmos. It makes sense algebraically. I'm more likely to make a mistake algebraically, and it's just easier to look at and trust in Desmos when Desmos kind of verifies it for me or even does it for me. Okay, so that's how we got the 3 points. Square root of 5, 0 is that one. 0, 2, and -2, 0. So that's how we found our intercepts, just using the finding the x-intercept and finding the y-intercept rule. Again, they might ask you for an expression that is a fraction or that it is a radical in simplest form. And so they won't let you put in this decimal. And so you need to understand how to get this decimal as the radical square root of 5 just by using this algebraic skills. But Desmos will verify to you that that is correct, or where to look, kind of, right? I know I don't need to put in for my y-intercept for this one. I only need my first, or my positive x-intercept. Good. All right, so that's how I would do those piecewise functions. Stop this recording. Thanks, guys. You did great. That was a lot.